Okay, let's go to the last chart. What about needs for data latency in terms of turnaround from photons to the sensor to products available on the ground? I mean, today, just to set some context, today with Landsat 8, we are more or less collecting over 400 scenes a day, and we're able to get those out as level 1T products, at least 85% of them within 24 hours, if not most of them. Now, is that sufficient? Can we relax that? If we did, what would be the impacts? Is there a driving need to really increase or shorten that latency?
For us, operationally, no. Everything that the center provides is wonderful. Next day delivery works just fine. We don't need 2-hour delivery. 20 hours, 24 hours is perfectly fine. That would work too. 48 would work. It might be a little tighter. We have like 5 or 6 production cycles, and that 48 hours in that particular cycle, that's when it gets tight. Like, we also use the MODIS data stream, and when we have reporting cycles and it doesn't quite sync, then we're forced to use an older product that a more timelier one would certainly improve our results.
I think the same is true with the cryosphere, especially, well, a lot of the applications of the cryosphere, we certainly don't even need the data the next day, but for snowmelt runoff processes in the spring, to really be able to observe them properly and input that data into models, if we were to have a greater revisit time, then we would definitely want the data the next day.
I was just going to note, within the constraints of revisit time, that any kind of disaster, people are really keen to have data. So floods and fires are the ones that come immediately to mind. And so when you start to think about 48 hours, I think you'd get some antsy firefighting teams and some other folks that would be a little worried. There's some, kind of sliding scale between that and what we, might be able to do.
John's got a question or comment.
Yeah, just a comment. We have, over the past couple months, been leveraging the 24-hour turnaround on 8 to a real advantage on our change detection algorithm, so we can turn it around. 48 hours, it would probably be too long. Does it need to be 6? I don't think so. I would try to hold to the 24.
Do we have any comments from folks off-site?
This is Rick Allen from the University of Idaho. Can you hear me?
Yep.
I worked with, collaborated with Martha Anderson on retrieving evapotranspiration from Landsat and other satellites. And in regard to data latency, I think in the future, as we continue to develop operational applications of water consumption information for near real-time operations of, say, reservoirs and irrigation scheduling, less than 24-hour availability would be pretty critical.
Great, thanks, Rick. Anyone else off-site? Okay, next question. How important is global coverage and seasonal refresh? Do we need to be systematically imaging the globe, striving to get cloud-free seasonal data? Is that sufficient? Do we need something more frequent? Curtis?
The geographic coverage issue would be a really hard one to go backwards on. I mean, in terms of, there are a few situations in particular where this shows up. One is Antarctica, for example, which is a challenge to collect image data for, and there have been some really valuable analyses done and things learned and stuff by being able to have Landsat scale resolutions of Antarctica. And so if that's what you mean by is global important and that sort of thing, then I think the answer is yes. Like the global coverage really is critical. There aren't parts of the world that we just don't care about.
In terms of food security, water security, those are global issues. And in the thermal band, if we're going to be tracing water available issues and limitations on water availability, we need the same kind of temporal coverage any part of the world that we're obtaining in the United States. So I would argue that seasonal is not enough globally.
If anything, I'd say necessary, but not necessarily sufficient, because as we move to pixel-based analysis, and that we've had a lot of discussion about the need for increased temporal resolution, there are a lot of areas that are pretty cloud covered. And so it's important to think about the constraints. You know, what does it take to get good seasonal acquisition in some of these areas? We know we have a lot of data, from which we can make these analyses, and I think it's part of our set of activities here in the coming months. But in the end, if we're moving to pixel-based analysis for almost all of our applications, then what we've been doing is absolutely essential and may not be enough. Curtis mentioned this concept of always on over land, which is something that we've been kind of striving toward, because if we get 80% cloud cover, it's 20% cloud free. That's observations on pixels that are quite important.
It may well be that the construct of one clear image seasonally is the wrong construct. I think...
Kill the LTAP.
No, I'm not sure we want to kill the LTAP, but I'm not sure that that's the right target anymore.
How would you prescribe it?
More frequent observations, but in essence, in terms of a criteria, you don't want to stop collecting data someplace once you have one clear image. I mean, that's the limitation. And so it was a useful and valuable construct for maybe, 13, 15 years. But I'm not sure it's the target anymore. Global coverage is, and as frequently as you can collect the data, you ought to collect it.
Any additional comments from participants in the audience? We have one. Hold on a second. We'll get to the remote site. Just a minute.
Don't kill my LTAP, baby. Sorry, Terry Arvidsson, Lockheed Martin. I wanted to just note that for Landsat 7, we have recently gone to a continental-only acquisition strategy. And that's to preserve the things that, the characteristics of the sensor, the ETM Plus, that it has a limited duty cycle, it gets too hot, et cetera. It just lends itself really nicely to a continental strategy where you turn on at the beginning of land and you turn off when you get to the end of land and you're over extensive water. And we do include some major island groups like the Caribbean and Indonesia, but we don't include other isolated islands, the Pacific Group, and some of the other maybe a little bit larger islands. And that seems to be working really well right now within the limitations of that. For Landsat 8, we're still being guided by the LTAP, but it's a broader one. We have a lot more resources available to us. We can take 550 scenes a day. We started at 250 with Landsat 7. And there's talk of, playing with it to see how far we can go. We may end up in a continental strategy for that, we don't know, or anytime you're over any kind of land. But for right now, I think we're doing the best we can with the 2, and we're going to learn from the continental strategy on 7, perhaps enough to inform future projects, future satellites, whether it makes sense to keep going in that direction. If you're over land, then you're on, and that's the end of it. But another question that I think you should have on your list is how much water should we be acquiring? There have been many campaigns over the oceans that we conducted with 5 and 7 at user requests and some of your customers. And there are benefits to the new sensors that will allow us to get more information out of data acquired over the oceans. So I think we ought to be including that in the mix of questions as well.
That's a good point.
I know it's Landsat, but are there ocean-based applications that could benefit from this moderate resolution sensor data?
We have another one or two questions here in the auditorium, and then I'll get to the offsite.
Let me comment on the philosophy of seasonal refresh. Back in the early 90s, when we were talking about Landsat 7, the driving requirement for coverage was to detect, monitor, and characterize persistent land cover change. As the operation of the satellite systems have advanced since the launch of Landsat 7 and the data became free, no cost, a lot of applications of the data and studies with the data have turned towards looking at intra-annual phenological changes. And that's where the seasonal refresh strategy falls down, because that's not sufficient for studying and observing intra-annual phenological changes. And so I think we are now, in talking about future systems, entering a new strategy for the use of the Landsat program or land imaging in general. I'm Jim Irons. I work at NASA Goddard.
Thanks, Jim. Roger Mitchell, MDA. So I just, a few weeks ago, I saw the collection for 16 days with Landsat 8, and it covered 95% of the entire continental land area of the Earth. So I'm not sure why there's any discussion of, do you have to collect it one season? Because you have no choice. If you're collecting everything, you're getting everything. So I don't know whether there's any discussion.
This isn't a discussion of 8, though. So what do you have for the future? What's the future mission requirement?
It's
Can
going
you
to get
maintain
worse.
that, or lower cost?
No, it can't. Frequency's got to get up there.
I believe we had a question from, or a comment from someone off-site. If you're there, please turn off mute. Okay, I guess not. Let's move along. Now we'll move into a couple questions that really kind of dovetail with John Crow's earlier presentation, but really looking forward, are there other sensor modalities that should be considered in the evolution of a sustainable land imaging program that could satisfy your current or evolving applications requirements? I'd like to, that's kind of a little bit of blue skying. Okay, I did skip one. Are there alternative data streams to those provided by the U.S. government that should be pursued, i.e., international or commercial applications? Now, Rick Mueller referenced, and Martha as well, the use of some of the other foreign systems and commercial systems. There's been a lot of growing interest and anticipation of the European Space Agency's Sentinel-2 mission. Should we be looking at those as alternatives or as augmentation, or how do these things fit in the mix?
Well, one technique we're working on to help gap fill between Landsat overpasses in terms of evapotranspiration retrieval is to fuse coarser resolution information that we get from something like MODIS. It provides us similar information but at coarser spatial scales, but potentially can capture some of the bigger rainfall events that might occur between Landsat overpasses. This is really benefited by having if we do this with Landsat 7 and MODIS Terra, it works beautifully because they're flying in formation and they're looking at the same angle. It's very, very easy to fuse that kind of information. So it's something we might want to keep in mind in terms of integrating multiple spatial resolutions of data sets that integrating that information is quite much easier if they're looking at the same thing at about the same time from the same view angle.
I'd like to comment on Sentinel too. There are many very strong similarities between Landsat data and Sentinel-2, and there are some augmentations in Sentinel-2 relative to Landsat as well. They're similar spectral bands, not the same. There's better spatial resolution. There are 2 sensors planned where it'll go down to 5-day repeat times with 2 sensors from Sentinel-2. And importantly, quite recently, we've had official recognition of a free data policy associated with Sentinel-2, and that's an issue. But I think in the long run, while we should take every advantage of Sentinel-2 data, I think it is best seen as an augmentation rather than as a replacement for Landsat data. And there are a few things involved. One is the thermal capability, right? There is no thermal capability on Sentinel-2, so that's an issue. And both in the application domain and in the cloud detection domain, and so those shouldn't get lost. The geographic coverage issue is significant. There are no plans to collect data below, I think, 56 degrees for Sentinel-2 in the southern hemisphere, and so that's an issue. The other is that we have never seen any Sentinel-2 data because there has never been any collected. And so to kind of sight unseen, be willing to jump with the program as important as Landsat into believing that something we've never seen is going to be a perfectly viable replacement for is, I think, a big leap of faith. And there are lots of, one of the interesting things about being involved, and I have been for a long time now with the Landsat program, is that there are many programmatic dimensions of the Landsat program that have shifted and adjusted and changed and improved over time, for example. And I think the Landsat science team has been more help with the programmatic dimensions than it has even with the sensor dimensions of the whole thing. So if you're going to cede control of the Landsat program and the programmatic decisions that get made to it to a foreign entity, you're leaving yourself open to no longer having control of the data stream that you're going to get for something that has been identified as being critical to U.S. interests all the way through. So it isn't just, are they going to collect the right kind of data, but there's the whole processing of the data to be considered, and there are all the issues that will come with management of the satellites once they're up and launched, and how frequently they would be replaced and all that sort of. So there's a lot more there than just do the sensor characteristics sort of meet your specs, if you want to think of it that way, in terms of this. And from my perspective, to have the U.S. lose control of a Landsat-style data stream that has become so ingrained in so many applications would be a big risk and an unfortunate one to take. So I think the augmentation strategy beats the replacement strategy in that context.
Augmentation might help with temporal resolution, clearly. And so it's something that is, I completely concur with the augmentation and as well as the relative strengths and limitations. One other thing we should be very cognizant of is that the Sentinel program, at least to date, has nothing like EDC. And so in the end, it's not even clear, independent of the nominal intent to distribute no-cost data, that they'll be able to pull it off anywhere like what the USGS and its contractors have been able to do with such aplomb. So I think that's another issue that we should keep in mind.
We have a comment or question from someone in the audience.
Just let me
Okay.
pile on here, one more
Sure.
thing. I'll just let you know that our group will be downloading Sentinel-2 the first day it's available, just to test it out, see what's the usability and feasibility, and why not, it's free.
augmentation is great. My key concern would be the registration, and really registration on a pixel basis. Because when we're using it in the kind of applications that we use for change detection, the pixel-to-pixel registration is key. And I've had a nickel for every scene I've orthorectified in the past. You know, I could take us all on a vacation. But I've really become spoiled with the excellent job that EDC has done, that we can download imagery over the web in less than 4 minutes and have it sub-pixel co-registered. It's awesome. Now, maybe if Sentinel could get the raw data into EDC, and EDC would put out an orthorectified product registered to Landsat, sampled at 28.5 or 30, your favorite, then that would be a winning project. So,
Do we have any comments from anyone off-site? Okay, let's move along. We're just about done here. Back to the question of whether there are other sensitive modalities that should be considered in the evolution of the program that could satisfy applications requirements. And this gets to the fact we're really looking at something long-term here, not just the next mission. How do we need to see the program evolve? What role does technology and fusion have? What are the appropriate modalities for us to be considering?
What's the sensor modality, sorry?
Oh, okay. Well, I'd say SAR data, LiDAR.
Oh, different types of sensors.
Could even be multispectral thermal imaging.
Well, I could say that LiDAR data would be beneficial again to energy balance assessments. We need to know what the surface roughness is, so to accurately know what the vegetation height is across the landscape is a big benefit to the energy balance algorithms.
I mean, certainly the absence of spaceborne LiDAR usable for measuring vegetation characteristics is globally the largest gap in observations in the current international constellation.
Any other comments from the audience? Anybody off-site? And again, this is one of those questions really that will fall under the NLI requirements work that John Crow and his team will be conducting over the next couple of years. And then the last question is, and this gets to be a little bit more blue sky and less maybe on the space segment, more on the ground, but are there different product types, access methods, and distribution services that the program should be considering? I mean, if you had all your data specifications requirements met, are there still other things that we should be looking at? Because the RFI did address some things about aspects of the ground system, so that's where this question comes from. And it also, again, is something that under the National Land Imaging requirements, when we get into the services domain, that we should be thinking about.
I think in addition to the movement towards higher order products, in the long run, I think there should be serious consideration given to providing online analysis capabilities that keep people from having to download massive amounts of data on a regular basis. If you could do your analyses online where the data resides, rather than having to move the data all the time to wherever you need it, it may in the long run be a cheaper solution than repeating the data over and over and over again in 87 million different locations.
Any other comments or questions? Comments from the panel? Otherwise, to the audience?
Yes, taking that one step further, NASA's invested enormously in ESTO and others in NASA and technology to actually bring onboard processing into a reality state. Also, there's a lot of distribution through sensor web, as it's called, which is this amorphous idea where people are able to get customized products, different atmospheric corrections. In fact, that's one of the ways EO1 is still surviving, is by bringing in extra technology money, and led by Dan Mandel and Stu Fries and others here at Goddard. So that ought to be looked at least, for maybe far into the distant future. And it will ultimately save money because we've discovered with EO1 that we couldn't really afford archiving the data in the normal way, but by automating everything and getting things down, it turns out it really lowers the cost dramatically. And the other piece of this is that once you've done this and introduced this capability on board, you can actually have multiple missions on top of each other with the same basic sensors. A simple example is you take Landsat the way it is, and you add an ocean band, which is very narrow, wouldn't have much use over land, but if you had an imaging spectroscopy front end, you could simply, when you got over the oceans, aggregate it. You could invent the Landsat bands by aggregating the imaging spectroscopy, and I hesitate to use hyperspectral, because I was forced to wear a badge the other day saying, by Alex Getz, take the hype out of hyperspectral. Okay, at any rate, so what happens is, if you have this broadened capability, you can customize what you're sending down. You can afford to have the narrow ocean bands constructed from the imaging spectroscopy bands over the water, aggregate up to 1 kilometer resolution, reducing the data load dramatically. So these are things to be looked at. I recognize they're not going to be on Landsat 9, but maybe Landsat 10, maybe my grandkids will see it.
Any other comments from the audience? Any comments from anyone off-site?